In the realm of mechanical engineering, gear ratios serve as a crucial indicator of the rotational speed correlation between interlocking gears. Generally, when considering two gears, the drive gear, which directly receives rotational force, and the driven gear exhibit an inverse relationship. If the drive gear is larger, the driven gear rotates more swiftly, and vice versa. This fundamental concept can be mathematically expressed as gear ratio equals T2 T1, where T1 represents the number of teeth on the first gear and T2 denotes the number of teeth on the second gear. The output shaft speed of a gear train is influenced by three primary factors: the input shaft speed, the number of teeth on the input gear, and the number of teeth on the output gear. The formula for calculating the output shaft speed is Naut equals Nien Zinzo, where Naut is the output shaft speed in revolutions per minute RPM. Nien is the input shaft speed in RPM. Zin is the number of teeth on the input gear. Zo is the number of teeth on the output gear. To illustrate, consider a scenario where the input shaft speed is 100 revolutions per minute. The input gear has 20 teeth, and the output gear has 40 teeth. In this case, the output shaft speed can be calculated as follows. Naut equals 1002040 equals 50 revolutions per minute. It is noteworthy that the output shaft speed is invariably lower than the input shaft speed, due to the mechanical advantage provided by the gear train. The gear ratio, which is the ratio of the number of teeth on the output gear to the number of teeth on the input gear, determines the extent of this mechanical advantage. In the aforementioned example, the gear ratio is 2:1, indicating that the output shaft rotates twice for every one rotation of the input shaft. Gear trains find widespread application in various domains, including automotive transmissions, industrial machinery, and clocks. Their simplicity and efficiency make them an ideal choice for transmitting power from one shaft to another, while also enabling speed adjustments.